Hello children. So today we'll start with Newton's third law of motion. Okay. So how does it states? Let's see for. It states to be as like this. For every action there is equal and opposite reaction. Opposite reaction. So this is one of the famous third law of Newton's. For every action there is equal and opposite reaction. Okay. So let us see. Say for example, force applied 1, 2. It will be minus of force 2, 1. Okay, we'll see how it is. A box will be here. And similarly a box also is here. So this box is exerting force. Similarly this box again is giving back its opposite reaction. So from this we have taken or concluded as 1 is giving energy to u. Similarly 2 is giving energy to 1. So here it is positive, here it is negative. Equal and opposite reaction is there. When it comes to here it will be possible, or if this goes to this it will be negative. So it is for every action there is equal and opposite reaction. Clear? So when one body exerts force, the other body also exert force. This is what we call it as third law of Newton. Newton's third law of motion. Okay. Let us now take an example like this. When a bullet is fired, from gun, okay, it moves with certain velocity in forward direction. Okay. When bullet is fired from gun, it moves with certain velocity in forward direction. As a result, it applies equal and opposite force of gun on gun. Okay children, when a bullet is fired from gun, it moves with certain velocity in forward direction. As a result, it applies equal and opposite force on gun. So let us see ಹೇಗೆ ಅದು apply ಆಗುತ್ತೆ. Taking an example of like this. This is a gun. Okay, assume this to be as gun. Okay, this is a gun where bullets will be placed or reloaded here. With this magazine, bullets will be coming over here and it will be moving. So when trigger is applied, now with a trigger ಮಾಡಿದ ತಕ್ಷಣ the bullet comes out. Okay. As soon as it triggers and the bullet comes out, again it reloads. So this is equal and opposite reaction. Apply ಮಾಡಿದ ತಕ್ಷಣ ಇನ್ನೊಂದು ಬಂದ್ಬಿಡುತ್ತೆ. Okay. That we call it as Newton's third law of motion. So this is an example. In textbook, let us see. See, here you can see accelerating force on bullet, recoil force of gun. So when we trigger here, it again recoils. Reload. Equal and opposite directions. Reaction. Equal and opposite reaction. So this is one of the example. Similarly, we'll take one other example like this. A man will be walking. Okay. Here, a man is walking. When he walk on the ground, our foot pushes the ground back. So, this pushes the ground back. And the forward reaction is exerted. So, one kaal hinde hod takshana obviously innond kaal munde hogutte while walking. So, one kaal hinde hod takshana innond kaal munde hogutte. Okay. The forward reaction is exerted by the ground on our foot, which makes it move forward. So, one dadmele ಒಂದು ಇಡ್ತಾ ಇರ್ತೀವಿ. So, it makes it one by one and it moves forward. So, this is how Newton's third law of motion is explained. Now, moving on to conservation of momentum. So, we'll see law of conservation of momentum. Law of conservation of momentum. Okay, where for a system some total momentum is constant provided on provided no external, or can also say as a non-external force that acts on the body. That we take it as law of conservation of momentum. So, for a system, some total amount of momentum irutte. Okay, some total amount of momentum will be there, which is constant provided, where no external force acts on body. So, it will be at constant and certain, and there won't be any external force acts on the body. Okay, this is how law of conservation of momentum is taken. Or we can even take it like this. So, it can never be created nor be destroyed, which is always conserved. This is law of conservation of momentum. So, how do we take it in mathematical form? In mathematical form, we can derive this. Say, for example, taking an example of car here, and let us take a truck here. Okay. So, mass is equals to the mass of car. I am taking the mass of car is m1. Similarly, we'll take the mass of truck, that is equals to m2. And again, initial velocity, let's take it as u1 of car. Similarly, initial velocity will be u2. And here, initial momentum will be m1 into u1, where here we can take it as m2 into u2. initial we are taking. And similarly, final velocity will take it as v1. And for the truck we are taking as final velocity is equals to v2. And again, final momentum will be m1 v1. And final momentum for truck will be m2 v2. So, when car and truck collide each other, when this collide each other, when car and truck both get collide each other, will get forces. So, force of car and truck, and here force of truck and car. So, it will be car forces on truck here. Car forces on truck, and similarly here truck forces on car. Okay. We can write it as FCT is equals to M2 taking it as force of car truck, that is M2 V2 minus U2, okay, divided by T. Similarly, we are taking of truck, where force of truck on car is equals to M1 into V1 minus U1 divided by time. So, TT gets cancelled. On third law of equation, by using third law, we'll get it as F12, as already I have shown, it will be F21. By this third law of motion, we'll get it as M2 into V2 minus U2 divided by T, that is equals to minus of M1 into velocity and initial velocity divided by T, where as already told, TT will get cancelled. So it will be, can written be as M2 V2 minus M2 U2. Okay. Which is equals to minus of M1 V1 plus M1 U1. Okay. By taking this on one side, let us take like this, M2 V2 plus, taking this here, negative sign becomes positive when it comes to this side. So, we'll move it on one side. That will become M1 V1, which is equals to, here it will be moving on to the other side, where the positive sign will be over here like M1 and U1 plus, negative sign becomes positive when it comes to opposite side. So, it will be M2 into U2. This is the law of conservation of momentum, that is initial momentum before collision and which is equals to final momentum after collision. This is what the law of conservation of momentum to be stated with the mathematical form. Okay, children. This is how it is derived, the law of conservation of momentum. And let us solve some problems. Based on this, let us solve some problems. Okay. Let us take one problem. The first problem. A bullet of mass 10 gram is fired from a gun of mass 6 kg with velocity 300 meter per second. Velocity is 300 meter per second. Calculate the recoil of the gun. Okay. So, we are calculating the recoil of the gun. Let us take bullet here. Okay. And let us take gun here. So, mass will be 10 gram and velocity is 300 per meter per second, and the gun mass is 6 kg. The mass of gun is 6 kg and velocity that we need to find out. Okay, so it is in grams here where it is in kgs. So to convert this to kgs, we have to divide it by 1000. So let us convert 10 divided by 1000. It will become 1 by 100 kg. Okay. So law of conservation of momentum formula, that is m1 v1 is equals to m2 v2. So that is m1 is 1 by 100, taking it as, and velocity is 300, which is equals to, where m2 is 6 and v2 is that we need to find out. Okay, let us find out v2. v2 is equals to 300 divided by 100 into 6. That will get it as 1 by 2 meter per second. So this is the velocity of recoil of a gun. Got it, children? This is the solution and hence we have proved. So let us take one other question based on the numerical problem. Car A of mass 1500 kg. Okay, car A of mass 1500 kg traveling at 25 meter per second, which collides with another car. So car A and car B we are taking in this question. Of mass of 1000 kg. Here the mass is 1500 kg, where here the mass is 1000 kg. Traveling at 15 meter per second in same direction. So both the cars we can state it as it's moving in same direction. Okay. After collision, the velocity of car A becomes 20 meter per second. Calculate the velocity of car B after the collision. Now let us take car A and here we'll take it as car B. So mass is equals to 1500 kg of car A and initial speed is equals to 25 meter per second. Final is 20 meter per second. And for car B, the mass is 1000 kg and the initial speed is 15 meter per second. We need to find out the final velocity. So final velocity we need to find out by using the formula of law of conservation of momentum, that is m1 u1 plus m2 u2 is equals to m2 v2 plus m1 v1. Okay, so let us take it as mass is 1500 into 25 plus 1000 into 15, which is equals to, here it is 1000 into V2 plus 1500 into 20. Taking. So from this what we'll get? 1500 into 25 will get it as 3700 and 37,500 plus here it will be 15,000, which is equals to 1000 V2 plus 30,000. Okay. So by adding this, what we'll get is 52,500 minus this 30,000 we are taking over this side. It will become 30,000, which is equals to 1000 V2. So 52,500 minus 30,000 will get it 22,500 is equals to 1000 V2. So that will be 22,500 divided by 1000. We get it 22.5 meter per second. So this is the velocity of car B after the collision. So it will be 22.5 meter per second. Clear, children? This is how the numerical formulas to be solved. So this completes your chapter. And I'll give you the exercise question and answers as well as the numerical problems also. You can go through with that. Okay. This concludes the chapter Law of Conservation of Momentum, the topic, and the chapter Force and Laws of Motion. Thank you.